wheat on a chessboard, which can be found on the Pickover book, page 102. So, what this is Sissa's chessboard. It is notable in mathematics for being showing the nature of geometric growth and progression. It's one of the earliest mentions of chess in puzzles, and it was brought about in the year 1256. So Sissa is basically like an inventor, and he knew that this Indian king really liked chess, so he was going to try and invent a chessboard for him. And so the legend goes that the king was going to reward Sissa for inventing his chessboard. So then the king asked Sissa what he wanted for his reward, and he replied to the king that he would just be happy with one piece of wheat grain on the first square of the chessboard, 2 grains on the second square, 4 grains on the third, and so on. And of course the king is like, all right, he said, this is what he said, and it's in your book, and that is all you wish, Sissa, you fool. So the king didn't really think about it at first, but there's, as we go here, there's 64 squares on a chessboard, and what you're doing is you're squaring each, 2 to the third power, you're increasing the power by 1 every time. So at the end, you're gonna have 2 raised to the 64th minus 1 because of the 1 at the beginning there. So, yeah, as you can see, the number of wheat grains is going to increase to a very large number. And, all right, here we go. 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709 million, 551,615 grains of wheat to be exact. So that is a lot of wheat. And the king didn't really think of that at first because he didn't realize how much it was actually going to be, so he granted him the reward. I also read a thing that said they were both kind of con artists. So Sissa was basically trying to con the king, which he did, but then to counter that, the king replied with, well, just to make sure that I don't cheat you, you should count every grain of wheat to make sure I've given you. So then Sissa didn't know that it would take trillions of years or whatever to do that. So the deal didn't actually go through. But so yeah. And then another thing that the book says is this many grains of wheat loaded on a train would basically wrap around the earth 1,000 times. That's how long the train would be. So then I got to thinking about this, and I wanted to see how much money that would be right now in today's market. So I've read there's a couple different numbers, but the average was basically 1 million of kernels per wheat in a bushel, and a bushel is like 60 pounds, so if you can imagine a bag of salt is 40 pounds, so about that much. There's 1 million kernels in that. So then if we divide the answer we get from the previous problem divided by 1 million, you get that, which is 18 trillion, 446 billion, 744 million, 70,000 bushels of wheat in today's market. So then you take that number of bushels multiplied by, I looked it up, it's the wheat market right now is basically $5 for a bushel of wheat. So then you multiply the 18 trillion by $5, and then that gives you a total of 92 trillion, 233 billion, 720 million, $370,000. So that is a lot of money, and I'm guessing back then it would have been even more. So here's a visual representation of it. On the left, you can see that for each square, all 64 squares, it gives you the 2 to the power, and it just keeps increasing. And then this one is really cool, I thought, because it actually shows you, they put wheat on it, and you can see that it keeps, so by the end, you're going to have this crazy amount of wheat kernels. So in the Pickover book, it gives an example on the next page. I don't know if anybody's looking at it, but there's like candy corn on the pages, on the squares, and then there's a little ladybug beetle thing, yeah, right there, sitting down there, and the pickover book asks you how many kernels, or how many candy pieces would the bug get. So then, if you count up the squares, the beetle's on 16 squares, so then I just did the square before it, so it'd be 2 raised to the 14 minus 1, which is 16,383 pieces of candy that the beetle would receive. So a little bit of digging deeper. These couple websites here just bring you to the wheat on a chessboard problem, and it kind of walks you step by step how to solve it, and gives you like examples of geometric growth and all that stuff. There's other things like the Fibonacci series, geometric series, arithmetic series. You guys have all learned about that in other classes, but that all deals with the wheat on a chessboard idea, is that things raise to the power and increasingly get larger. Yeah. And then there's other things on there, like one question a student asked is how much wheat would it take to fill a swimming pool that's 6 feet deep, and just different cool stuff like that. So there is my photo references and my actual references. Thank you.